All right, let's make a very quick video and talk about this example. Imagine you're interested in the relationship between CEO salaries and return on equity. Okay, return on equity, if you don't have a finance background or econ background, basically how much return is the CEO or the company is making on per dollar of the equity. Okay, the equity of the firm, right? So this is what we call return on equity. So if it is 10%, or you're making 10% on every dollar of the company, right? So you might think that there should be a relationship between the two, right? If the ROE of a company is higher, so the salary maybe should be compensated more, and that's the case. So let's explore that. Let's use the data from the Wooldred and see if that's the case. So what is a regression model? We are using simple regression model. Simple regression model. Only one explanatory variable. Salary is equal to beta 0 plus beta 1 ROE plus U. So salary is reported in thousands of dollars, and ROE is the average return on equity of the CEO's firm. And what are U's? So U's are unobservable. So again, it can be, you can think of, okay, salary depends on many other things, but for just for an exercise, I'm going to ignore all of them. I put them in the U variable. Okay. Then we are going to use OLS. OLS is going to give us back this fitted line. The fitted line is salary hat. Be very careful. Here we have salary, here we have salary hat, because this is the estimate. This is a fitted line. This is the estimated value. This is a predicted value for salary. It's going to be 963 plus 18.5 ROE. Now let's interpret them one by one. So it's starting with the intercept interpretation. Again, even though we said we don't pay too much attention to that, but let's see if it makes sense here or not. Even in this setup doesn't make sense, because it says that if ROE is equal to 0, so if I plug 0 to ROE, so what do I get? The salary is going to be 963, what is the unit? $1,000. So if you're a CEO, you do nothing, your return on equity is 0, you will get back almost $1 million. Does that make sense? Absolutely not, right? So again, we are not really into interpreting the intercept in a simple regression model. However, we can perfectly interpret this slope variable, right? So how do we say that? We say if the return on equity increased by 1 unit. So what is a unit here? It's a return, so it's percent. So if the return on equity increased by 1%, then the salary is going to increase by 18.5 thousand, or $18,501, holding everything else constant, right? So that's the interpretation. Then here's a question for you. What is the predicted salary when ROE is equal to 30? So simply plug 30 here and do the math and see what you get for predicted value of salary, right? Now let's look at the data. So this is the what we're going to eventually give to R, and R is going to give back this equation to us. So what do we have? These are observation numbers. So it's a cross-sectional data, right? So we have observations. There is no sign of time here, so it's going to be cross-sectional. Then we have ROE, salary hat. This is our Y hat, and this is our U hat. Okay. So ROE is observable. That comes with the data. Salary is observable. That comes with the data. The rest of them is going to be calculated by OLS in R, right? So OLS is going to use these two columns, give me back this equation, then I'm going to use this equation to make some predictions about my Y hat. So I'll get this column, and when I have this column, then I can say, okay, the difference between Y and Y hat, these two columns, the difference between these two columns is going to be my U hat. And U hat, remember, we gave it a name. It was residual. Okay, so let me go ahead and erase all these lines, make it clear. Now look at a couple of observations. So for instance, this observation number 1. So what do we calculate? How do we calculate U hat? U hat is going to be the difference between salary Y minus Y hat. So if I do 1095 minus 1224 point something 0.58, it's going to be equal to minus 1.29, 0.581. So the residual is negative, right? Residual can be positive or negative, right? So this, if I want to give you a representation of the residual, you can this is my regret. Imagine this is at the end of the day. This is a fitted line. And imagine this is a true value. Actually, let's plot some of them. So here, let's plot observation number 1. So maybe the salary is $10.95, but the model predicted to be $12.24. So this is observation number 1. And then let's do another of the observations that the U hat is positive. Let's do observation number 5. I'm going to use red color. So observation number 5, the true salary is $13.68, but the model predicted to be $12.18. Okay, I'm here. So in the first case, y minus y hat, it's going to be a negative number. So it's minus 129. I'm just rounding up numbers. In the second case, y minus y hat is going to be a positive number. It is 149. Okay, so in the first case, this means that u hat, and look at the subscript I'm using, 1. It's less than 0. Oh. U hat 1 is less than 0. In this case, U hat, what's the subscript number? Look at the observation. 5 is greater than 0. So whenever U hat is less than 0, we call sample regression function or the model is over predicting. Look at that. We are over predicting this number. It's supposed to be 1095. We said it's 1224. So we are over predicting. Again, whenever U hat is less than 0, the model is over predicting. Whenever U hat is greater than 0, the model is under predicting. Look at that, we are under predicting here. The true value was 1368, we are under predicting it to be 1218. Okay. All right, so again, this is the graphical presentation of the regression line. And for the last time, I'm going to walk you through the distinction between sample regression function and population regression function. The dashed line is the population regression function. This is what we theoretically showed, that the expected value of salary given ROE is equal to this equation, right? Be careful, this line is unknown, this is unobservable, but it is unique. However, we use Wooler's dataset, we use one sample, and in that one sample, we ended up with one sample regression function. If I use another sample, I ended up with something else. The goal is to find, we hope that, so this is the most subtle part of the course, I believe, that students get confused. With regression analysis, we hope that we get close to some line, we are going to figure out some line which is as close as possible to another line, which is, by the way, not observable. Think about it. So all you're doing in regression analysis is to find a fitted line, and we hope that that fitted line is close to some hypothetical line that we are never, ever able to see. So what's the point? What are we doing? Well, this is the best we can do. Do you remember first day I told you that there is no single true model out there? This is what we mean. There is no single true model out there that can say there's this exact relationship between ROE and salary in the entire population. But should we give up there and say, okay, there is no true model, okay, I give up? No. You use data, you do your best, and you hope that this line that you just predicted is as close as that hypothetical line. Okay, so this is the most subtle part of understanding the regression analysis. All right, so let me pause the video here, and the last one, which is the fourth video, is going to be a concluding video going over some algebraic properties of a simple regression function.